Thank you. Let's consider what we mean by, okay, first of all, what is a distribution of sample mean? Well, let's read this definition first and the steps for how to get a distribution of sample mean, all right? Andrew, go ahead, please. Yeah. Probability distribution of
Probability distribution of all possible values of variable x computed from sample size of n from a population with n of sigma.
All right, thank you. By the way, I should put in the term in here. Thank you, Andrew. Not just variable x bar, but random variable x bar, right? The term random in there is definitely important because that's the first step for us to obtain this sample size from the population. Again, the population, we don't know the shape of the population. It might be a normal shape, it might be skewed to the right, it might be uniform distribution. Honestly, it doesn't really matter what the shape of the population is. The important first step is that the obtaining of the size n sample coming from the population should be by simple random sampling. Okay, it cannot be there cannot be any kind of bias, voluntary bias or response bias coming from obtaining the samples. So other than that, we cannot obtain what we call a random variable x bar. Okay. Next one, as we may notice in here, definitely if we obtain a sample, it already has a size, right? So how many you took from the population? That is your number of respondents. Again, it should be randomly selected. That is your n or small n. The population already had its certain mu and sigma. So as you may notice, those are Greek letters, then those are the population mean and standard deviation. Okay, so again, the population in here has a mean and a standard deviation. However, it doesn't actually say specifically that the population should be normally distributed in the first place, right? So it doesn't have that condition yet. Once again, how do we do that? Once again, from the population, we do random sampling. Okay, so we do random number generator, any method of random sampling technique, please use that one. After that, compute for the sample mean. Okay, so there are different ways of computing for the sample mean. You may group the data, or you may treat it as a raw data and get your mean. Next, let the population be finite. So when you say finite, that is countable. Okay, so let's say, what is the population of the United States? Well, we have our census to verify how many people are actually, as a population in the United States. So that's finite, it's countable, right? It's not infinite. Repeat until all distinct simple random samples of size n is obtained. So you keep on repeating this, what we call random sampling simulation of size n. Now, what now can we say about this one? And let's read this one in here and apply that for this specific case for number 18. All right. Well, let's read it first. Angelina, go ahead, please. Number 18.
A simple random sample of size n plus 20 is obtained from a population with a mean of 64 and a standard deviation of 15.
Thank you. Right. So, from the population, we already obtained a sample. Respondents, how many respondents are there? 20 respondents. Okay. And again, important thing, it says in there that the selection of the sample is by simple random. Okay, so you did a simple randomized sampling. Now, it also says in here that the population already has, it's given and obtained mean and standard deviation. Again, these two are the mean and standard deviation of the population, not of the mean 20. Okay, so this is for the population, not on those 20 yet. Okay, now, what now? What can we say about this one? Let's read letter A. How do we do this? Juliana, go ahead, please.
What must be true regarding the distribution of the population in order to use the normal
X bar. All right, thank you. Right. So what can we say about this population? Did it say it's a normally distributed population? Did you see any term or any word that says it's a random probability distribution for the population in here?
No.
No, right? Thank you, Mason. So in here, it says no mention of what? The population to be what? Normal. So again, there's no mention of the population to be normal. And that's basically one of the requirements for, getting the sample distribution or sample sample mean distribution. Again, the population should be normal if your sample mean is irrelevant. Okay, because your sample size in here is how much? 20, right? Is it big enough or too small? Honestly, it is too small. If you can recall our assessing normality from yesterday, we said what? How big should your sample size be? To at least treat it as a normal probability distribution. 30. Very good tip, right? But since in here, it's too small, 20, right? So with that being said, the first condition is, since the sample size is what? Too small to assume normal distribution of the sample itself, then the first condition is what? That the population must be what? Must be, first of all, normally distributed. Okay, so that's the first condition. The population must be normally distributed. And, well, actually, that's the second condition. The first condition is what? Which is actually achieved in here already by the sample. And what is that first condition? How did he choose those 20 respondents?
Random.
By simple random sampling, right? So honestly in here, the first condition, step 1 was already satisfied, okay? That the sample were obtained by a simple random technique, right? But the second condition has to be satisfied as well. Why? Simply because our n equals 20 is not enough, right? Not big enough to assume normal distribution. But still, we can assume this sample mean to be also a normally distributed sample mean if, in the first place, the population itself is, stated to be a normally distributed population. Get what I mean, right? Once again, if the population is normal, then it doesn't really matter how big of a sample size you get in there, right? Whether it's less than 30, right? Well, hopefully not less than 10, okay. Even if it's less than 30, as long as you get it from population that is normally distributed, and you also did it by simple random sampling techniques, then yes, you can assume normal distribution, and all the properties of normal distribution that we did in the past, z-scores, normal dist, all of those probabilities and proportions should apply. Other than that, then we cannot do those. Well, there's one more technique, and what is that? We do 7.3 yesterday on how to assess normality, even if the population size, the sample size is not big enough for that. Okay, let us consider now. Okay, so here, what does it say in here? So we have satisfied, if we have satisfied that the population is a normally distributed sample, in terms of its shape, again the population, then we can assume that this sample size, even if it's 20, should be normally distributed as well, okay? Now, assuming that all of the conditions are true, what can we say then? Describe the sampling distribution of X bar. Again, when you say X bar, that is the what? the sample mean. Okay. So again, assuming that the population is normal, and also assuming, well, it already says in there that the sample were obtained by simple random sampling, then what can you say about the shape of the sample mean distribution? Will it be normal as well?
Yes.
Yes, thank you. Right, once again, if the population is normal, regardless of the size of your sample, as long as you did simple random sampling, then we can say that your sample mean distribution should also be normal. However, its mean and standard deviation should be as follows, all right? So it says in here, mu x bar, what does it mean? The mean of your sample distribution should be equal to the mean of the population. However, the standard deviation of your sample mean, what do? You divide it by the square root of the sample size. Okay, so again, the mean should be the same, again, assuming that they're both normal. But the standard deviation of the sample mean should be over the square root of the sample size. Okay, so with that being said, let's consider in here. Letter B. Let's read that one and read it. Okay, Brett, go ahead please. Assuming that the requirements.
Assuming that the requirements described in part A are satisfied, determine that.
What's that? That's a probability that your x bar is less than what?
67.3.
Thank you, right? So, what's the probability or the chance that your x bar or the sample mean is less than 67.3? So, again, if we assume this one to be correct already, right? That the population is what? Normal as well, then we can put in here the following. Normal dist, we can use this one simply because we already said the sample mean is assumed to be normal already, right? Now, what is our mean? What's our mean in there?
64.
64, thank you. Comma, what's our standard deviation there?
17.
17, thank you, okay. And what do you want our probability to be? Less than what? 67.5? Is that what it says? 0.3? 67.3. Now, how to clearly see it in here? Again, we're using decimals, by the way, for this. Again, you can also use StatCrunch for such, okay? So what do? On the x-axis, we're gonna put what? Well, if it's 64, to assume, if you're assuming it to be normally distributed, we put what? Minus 3 times the standard deviation. What's our standard deviation? 17, right? Okay. And again, we are assuming it to be normal. That's why we are trying to impose the, what's this? The empirical rule, right? Okay. So that's the mean minus 3 times the standard deviation. That's the 99.7 on the left. And what's the other one? Still the same, 64 plus 3 times the standard deviation, 70. Okay, and with that, let's see in here, our y-axis is the proportion, and always proportion is what? From 0 to 1, right? So 0 to 1. And definitely this one can be adjusted, because as you may notice, like, Mr. Deal, that amount is just kind of like little, right? Well, you can adjust it accordingly, right? Again, I put in here 0 to 1. However, you know what? Let me just X this out just for you to see it. Okay, once again, my normal distribution for the sample mean is 64 according to your population mean, and your standard deviation is 70. Okay? It says the probability of your x bar being less than 67.3, all right? The probability that your x bar or the sample mean, random sample mean, is what? 67.3, right? So that means that is the maximum, and your minimum should be what? You can put some number in there, like say 0, okay? Or just leave it as blank. In short, if you leave it as blank, it's gonna put in there negative infinity, okay? Now, in order to visualize it, what did we do? Standard distribution, right? We say that 99.7 rule, that's the mean minus 3 times the standard deviation. And in here, that's the mean also plus 3 times the standard deviation. Y is 0 to 1. Technically, it's 0 to 1. However, you can adjust it further if you are saying like you want a better visual, right? As you may notice, the top in here is what? Less than 0.1, right? Okay, so in short, you can adjust this accordingly if you want to, just to clearly see it, okay? So here it is. Okay, there we go. So, let's see. Is that, what number is this again?
B.
Letter B, number 18, okay? So it says in here, assuming that the requirements described in part A are satisfied, again, that the population is normally distributed, even if your sample size is, how much is your sample size again? 20, right? Okay. So, we forgot some, this is just for the population, okay? But for the sample, what we're gonna do with the 17? Divided by, what's your sample size?
20.
20, right? So square root of 20. Good guys. Once again, we said in here, regardless of your sample size, assuming that your population is normal, then your mean will still be the same as the population. However, for the sample mean distribution, your standard deviation of the population should be divided by the sample size. And how big is the sample size for this one?
20.
It says 20, right? That's why in there, I put what? 17 over square root of 20, okay? Yes?
So if you're doing this in StatCrunch, how would you do the last step? Or would you have to switch to this?
For the StatCrunch, we'll see that one later, all right? Let's finish this one first, okay? So as we may notice in here,
Yeah.
okay, so once again, this is for the mean, or standard deviation for the mean, all right? So 67.3. Now, for the population, and let's compare them in here, right? So again, for the population, we don't have this. Instead, we just have that one, okay? And see in here, how much is this one? 67.3 as well, okay? So here it is. Are they the same? 64 as the mu, population mean, and standard deviation is 17, all right? And as we may notice in here, we are comparing the one from the what? The one in black is for the population, all right? With mean and standard deviation, okay? That's what's that? 57, okay? Now in here, this is in purple, that is for the sample mean. Because in the sample mean, your mean is still the same as the population, but the standard deviation should be divided by square root of 20. Get it, guys? See this one, this two in here? Again, the black in here is for the population, and the purple in here is for the sample mean. Okay? The only difference between these two is that the standard deviation of your sample mean is what? Divided by the square root of the sample size, 20. Questions? Questions, guys? Now, how do we do this on our StatCrunch? Well, similar to what we did in the past. Let's see what we get from that. Okay, let's go back in here. Let's go to our StatCrunch. Let's see. Where's that StatCrunch again? Course tools. StatCrunch. Okay, in our stat crunch, guys, just disregard whatever you're seeing on the numbers in here. Just disregard that, right? You just go to stats. You go to calculators. You go to what? Normal distribution. Okay, so here it is. Now for the population, let's do it for the population first, right? Let's click on standard, and let's put in here what's the mean again? 64. What's this one? 17. X less than what? 67.3. Okay. Click compute. Okay, so that is for the what's this? For the population. Okay, and you can click on this 68, 95, 99.7 as well to verify what we did a while ago with our decimals. Okay, yeah. Because if you click on that one, you see those 13 to 115. Those are the 3 standard deviations above and below. Okay. Is it the same as what we did from the population a while ago? Still the same, right? 0.50,
Yeah.
0.577. Anyway, for the sample mean, we're gonna do the same. Okay, stat calculators normal. Okay, here it is. However, the only thing that will be different. Okay, so again, the mean is the same, 64, but the standard deviation will be different, right? What is that in here? What's 17 divided by square root of 20? On your calculators. Let's see that one on our calculators first, right? 17 divided by square root of 20. I got that one to be 3.801, right? So I'm gonna copy this one and just plug it in there for the standard deviation instead. Okay. There we go. 3.8. Because that's standard deviation of the population, 17 over square root of 20.
Yeah.
And in here, I'm going to put what? 67.3. Click compute, and there it is. Okay, so what is the... Okay, as you may notice, in terms of the number details, it's comparable. Looks like it's similar, right, to what we see on our decimals as well, right? 64 for the mean, standard deviation 17. Again, this is for the population, right? This is for the sample mean, okay? Still the same mean, 64, but this is 3.8 instead. Why? Because that's 17, the standard deviation of population, over square root of the sample size. And it says the sample size is how much? 20. Questions with what we did? Okay, so again, it doesn't matter whether you use StatCrunch or decimals, it looks like they're the same values anyway, okay? Let us continue with this. What does it say next, okay? In this case now, let's read this one in here, upper leg length, and see how we can okay, let's read this number in here. Problem number 20. Robbie, go ahead please. Upper leg length.
Upper leg length. The upper leg length of a 20 to 29-year-old male is approximately normal with a mean length of 43.7 centimeters and a standard deviation of 4.3 centimeters.
Thank you. Letter A. Consider letter A. Read letter A, Robbie. Please, thank
What
you.
is the probability that a randomly selected 20 to 29-year-old male has an upper leg length that is less than 40 centimeters?
All right, thank you. Okay, first of all, let's see the conditions if that is satisfied to actually imply that the sample mean distribution is normal. First, what's the first condition? How is the selection of the sample done? Simple random sampling. Is that correct? Let's see. It says in here that a randomly selected 20 to 29-year-old male has an upper leg length that is less than 40 centimeters. So yes, we are correct with that. Okay? Yep. It says that it's randomly selected. What is the second condition as well for this?
It says that it's normal.
That the population is normal. Is that correct? Well, does it say in here? Well, it says in here, right? Yeah. it is approximately normal. The entire population of 20 to 29-year-old males in terms of their upper leg length. What is the mu? It's given a mu. And what is the sigma? They're given a sigma. Oops. You good, guys? Okay. Next one. It doesn't say, however, in here, however, how many males were randomly selected. Okay, so if that is the case, what do we do here? How do we get the value of less than 40? So in here, we're gonna put what? Normal dist in decimals, okay, normal dist. What is our mu? 43.7, comma, what's your standard deviation? 4.2. We don't divide this by square root of n simply because we are not given any sample size anyway, right? So just leave it as it is. Now it says what? Less than 40 centimeters. So in short, in your probability distribution factor, what is your minimum and what is your maximum for this? It says your upper leg length should be less than 40. So that means 40 centimeters is what? Is it the maximum or the minimum values? Value?
Maximum.
Maximum. Very good. So this is 40 and this should be what? Blank. Again, if you leave it blank, it will just say negative infinity anyway. Okay? Let's read letter B and see how we can work on letter B, all right? JC, go ahead please. Letter B.
A random sample of 9 males who are 20 to 29 years old is obtained. What is the probability that the upper leg length is less than 40?
Thank you. Right. So the only difference with letters A and B is that in letter B, we are given how many respondents were selected. How many? What's the sample size? 9. Okay. So with that being said, we're going to put in here the following. Normal dist. 43.7 stills. As you may notice, the population and the sample mean in terms of their center value is the same, right? However, what's the standard deviation in here? That's going to be what? 4.2. And what we're going to do with 4.2?
Divided by the sum.
Very good. Divided by the square root of 9. Yes. All right. It's still the same question. So that means still the same on your PDF. Get your minimum as blank. That's negative infinity. And your maximum to be still the same, 40. Get it, guys? What we did with that? Okay. Next, letter C. Let's read letter C and how we do that one, okay? 3. Go ahead, please.
What is the probability that a random sample of 12 males who are 20 to 29 years old results in a mean upper leg length that is less than 40 centimeters?
Thank you. All right. So in short, that's the same. Normal or similar. Normal dist. Still the same sample mean. But in here, that should be what? 4.2 over what? Very good. Square root of 12. Right? Because it says there square root of 12. That's the sample size. And still the same. Less than 40 centimeters. Right? So it's still the same. Your minimum is what? Negative infinity. And your maximum is how much?
40.
Very good. 40. Right? That's you. Now, let's compare each of these and see how it looks like, okay? Because that's going to answer letter D, the effect. As the sample size increases, what's happening to the probability, okay? Let's verify in here. So what's the first one? Normal dist. What's this going to be again?
43.7.
Thank you, right? So let me just erase this one just to clearly see this part in here. By doing the erasing right. Okay. And again, you can also do stat crunch for this. Honestly, it doesn't really matter if you do stat crunch or decimals, you're gonna get similar values, all right? So once again, 43.7, right? 43.7 And what's the standard deviation again?
4.2.
Thank you, 4.2. And this one should be 40. Okay. So that is for the population. Okay. Let me just change this one to be what? 43.7, right? So that's 4.2. So I can put in here the following, right? 43.7 minus 3 times the standard deviation 4.2. Okay. Now on the same in here, I'm gonna put the same 43.7 plus 3 standard deviations above as well, right? So that's your. I'm basing that one from our rule of. There we go. Probability is 0 to 1. Right, so here it is, and you can adjust it accordingly as well. So that is what? Without the sample size given, okay? Now, I'm just basically gonna copy this, put it in here on the second one, okay? And then, divide 4.2 by how much? Square root of 9, okay? So that is the one in black in here. You know what? I'm gonna change this y to something that we can visually see, okay? 0.5, okay? Okay? This is what again? 40. And I'm gonna do the same in here for what? Sample size, oops, 12, thank you. Control C, put it in here. Okay, sample size 12. Still click on the cumulative distribution and put in here 40 as well, okay? Oops. Okay, so as you may notice in here, this is for no sample given, no sample size given. This is a smaller sample size. This is a bigger sample size. Now you look at the probability. What is happening to the probability of x less than 40 as your sample size increases?
And decreasing.
Very good, right? As you may notice, the probability decreases as your sample size increases. Okay, and that's good analysis for that, because essential as well, not only good but essential, important analysis, because that explains our letter D. Okay, let's do letter D. OB, go ahead please. Yeah.
What effect does increasing the sample size have on the probability? Provide an explanation of this result.
Thank you, right? So, what do we notice? It decreases. And what is the explanation of the result? Well, as you may notice, as your sample size decreases, what's happening to your standard deviation? It decreases as well, right? So it lessens the spread. So that means yeah, it lessens the spread. That means it also lessens the probability that your x in here is less than that random variable obtained. Yeah, well, assumed to be 40 centimeters or such, right? We haven't dealt with the central limit theorem, but that will be used. Okay, the question now is this one, right? What now if the population is not normal, right? Because in here, the first condition is that, well, you want the population to be normal first, and random sampling to be done on the sample. What if, in the first place, your population is not normal? How can we analyze and can we assume normal distribution? And that will be our central limit theorem, where it will take place and see, how we can assume normal distribution on the sample, even if the population is not normal. Might be skewed, might be uniform distribution, so we'll see, all right? For now, we have done this one, again, the first two cases. First condition, it should be a simple random sampling was done. And second condition is that what? We have the assumption that the population is normally distributed. Okay? Thank you guys, and we're gonna